Hello, folks. Welcome to the DMTF Redfish Forum's 2024.1 and 2024.2 release webinar. My name is Jeff Otter. I'm one of the Redfish Forum co-chairs, and with me, as always, is Mike Ranieri.
Hi, I'm Mike Ranieri from Dell Technologies, and as Jeff said, I'm the other Redfish Forum co-chair.
All right, and with that, let's get into the release material. So we are covering two releases this time, and as the Redfish Forum operates on really a train model of we do a release whenever the schedule says that we should do one, and but we also will add a release here and there if there is an industry need for some new functionality or any other reason that comes up. So that's what happened this time as we were processing and releasing the 2024.1 release. It became clear that we were going to do another release very soon after, and so instead of dividing these up, we decided we'll just schedule one webinar to cover both. So that's what we're doing today. And this is old hat for folks that have been here before, but want to call out the various documents that can help you with the release materials. The first is the number of documents that are generated for every release of the Redfish spec and schema. The data model specification and the resource and schema guide. These are documents that are intended to be, more human readable versions of schema. So it takes all of the information from the schema files and then produces it into a kind of more of a guide or an API documentation format. And those are all available. The same is true for the standard message registries that's produced in the message registry guide. And then lastly, if you're just stumped as to where something lands, there is an alphabetical list of properties that goes all the way across schemas. So you can help you to track down a specific property if someone's looking for something. Something that we did by request I think it was last year, was a new GitHub repo called Redfish Publications. This repository contains all read-only copies of the schemas and the standard message registries. This allows anyone to clone that repo and therefore keep themselves a local copy that can be very easily synced with the latest releases. So every time we do a release, once that becomes public, this repo is updated with a new pull to keep that all in sync. The format of the repository follows the contents of the schema and the registry bundles, DSP 8010 and DSP 8011. So you'll see a number of folders there that contain the schemas in the 4 supported schema languages, and then another folder for registries. And one other reminder is one of the things we do as a forum is produce open source tools to test conformance of an implementation to the Redfish specification. So there are 3 tools that are part of effectively a suite of those. The first is the Redfish Protocol Validator. This is really your first stop for any new implementation. This is really helpful for test teams, and hopefully end users are only using this to diagnose some other problem. But the Protocol Validator checks the conformance to the HTTP components that are kind of more called out and tightened down by the Redfish specification, and especially in the areas of response headers and specific HTTP status codes. So that tool has been recently hardened to try to survive bad behavior by implementations, so that it will produce a report at the end of the run. It may show an awful lot of faults, but a lot of times those are cascading. So we continue to work on that tool to harden it and make it easy to run. But my guidance for anyone doing any implementations is run all of these tools. The protocol validator checks the protocol. The service validator checks your conformance to the standard schemas. If those tools are not working for you, it indicates that there is at least two problems, a problem in the implementation and a problem that the tool was not expecting to find, and therefore another unexpected piece. Please open issues against those tools on their GitHub repos, because we strive to make those tools survive even the most egregious faults, so that they can produce useful test output for folks to fix the implementations. We do, and we continue to do that and continue to learn. The last tool on that list is the interop validator. This tests an implementation's conformance to a defined Redfish interoperability profile. Those are starting to show up more and more, especially from organizations like the Open Compute Project, which some of us are also involved with. But those the profiles help to define set requirements for specific types of products and what portions of the Redfish schema they should implement. And so that's a way for someone to validate that that a particular implementation meets the requirements set forth by a profile. Lastly, there's a white paper that was written again, I think also last year. It's available for download on the standards Redfish page, called DSP 2068, and that is a conformance tools white paper, and that summarizes basically what I just said, but kind of lays out how to run the tools, which tools are which, and it's a short white paper, but really easy to hand to somebody that wants to get started with all of the validation pieces. All right, so now let's get into the releases. So Redfish release 2024.1, this occurred back in May of this year. And here's the summary of all the componentry. So it starts with just an errata release of the specification. So there was just some clarity given around resources that might be, as we would say, transiently unavailable, something that could could be going through a configuration, or something that has like a device that has been removed or has not yet been initialized. So it just gave some clarity of that in the specification, and then we also clarified some return code usage on the expand query. And I think yes, and also that just clarified that that privilege enforcement is required when you send events. So if you cannot subscribe to events from resources that you don't have privilege to access. That was always the case, but something to make clear in the spec. The schema bundle, as I said, DSP 8010 2024.1, so that contains the updated schemas that were part of this, and I'll get through that. There were 29 updated schemas, and I'll get through that in a second. The message registry bundle, we had a couple messages added to a few registries, adding some more items to what's called the platform registry, and this is the platform is trying to be a generic word for basically a computer or a computer-like thing. So it looks very much like like system level events. So you'll see we added things about an NVRAM clear or a security bypass switch had been asserted. These were common features in many server implementations, and so was worthwhile to create standard messages for those things. There was also a couple other pieces that were just minor additions to cover cases that just had been missed. And a word on these is that these registries are intended to provide standardized error messages or just conditional condition alerts for any of the equipment that's covered by the Redfish schemas. So if you have a need for something that sounds like an industry facing condition or an event, and I think that security bypass asserted is a good example of that. Please provide that feedback to us. It's very easy for us to add messages, and you'll find that many OEMs have exactly the same content, just with different message text, and so providing a standard for that helps all of the downstream tools that are actually trying to do something with eventing. the other portion that was updated for this release bundle was the interoperability profile specification. So that moves up to version 1.8. This adds an expansion of our use case that was added back in 1.6, and I'll get into the details of that. But trying to again further improve and simplify the process of creating profiles and making it easier for both the profile author and for anyone attempting to use the validators to see what what an implementation has done or has not done. So, like I said, in the 29 updated schemas, there is really just a lot of individual pieces that were spread throughout. We won't go through the gory details of all those. The changelog is available in DSP 8010. There's also the release history deck or the Redfish, just the release. The release presentations that are both available on the DMTF Redfish standards website, which will show you the link. Oh, there it is, the bottom, by the way. There are slides in those decks that go through in detail about every addition to the schema. So the things I'll call out here were some replacements for throughput reduction in CXL devices. That was a kind of a misnamed and misunderstood property when it was added. So the throughput reduction support has been replaced, and I believe that's in a different object now than where it was originally, and now called temporary throughput reduction supported. Part identification for sensor. This was added for products that have sensor accessories, typically like an external temperature sensor or an external humidity sensor, something that would actually be a user replaceable part, and so has all of these make, model, and serial number kind of components. So we've added that to sensor, and then there was just an oversight. So the ResetMetrics action was added, and we have this on all of the quote metrics related schemas and resources. So that was just missed, and so was added to port network adapter and network device function metrics. And as I already said, all the details of that can be downloaded from the Redfish standards page. So a little bit of detail about the use case type added and these new values that were added for in the interoperability profile specification. We previously added the concept of use cases, and that has made it a lot simpler to create profiles for different types of devices where they share the same schema. Perfect example would be a non-volatile DIMM as opposed to a DRAM device. You will set out very different requirement or very different set of requirements for those based on that device type. You could do that in the profile using conditional requirements, but that becomes kind of a hassle and very repetitive to do that on dozens of properties. So with use cases, it allows you to instead specify a definition of the use case and then essentially produce individual sets of requirements that are set with a single condition. So the way that this works now is it would be like saying, if this is an NVDIMM, then here are the 24 things that I need. If this is just a DIMM memory device, a DRAM device, then here's the set of requirements I have. So it makes it much simpler to do that. What we found is, as folks started to utilize that functionality, was that sometimes, especially in the metrics and other subordinate resource types that are underneath some of these major subsystems like drive and memory and port and chassis, you want to be able to do that same selection to say things like, well, the drive, if this is an SSD, I have a set of requirements. If it's a rotational media, I have a different set of requirements for drive metrics. things. But in order to make that selection, you need to know what type of device it is, and that is not specified in the in the drive metrics, but it's in the parent resource. So instead of trying to do generic references to other resources and having a lot of complexity, we realize that there's probably only a few of these cases where you need to specify things that are really defined in the parent part of the tree. So we just said, well, you know what, we'll just handle that in the tool, let it know about the specific things that it needs to chase down. And so we've added 5 new use case types that allow you then to specify, how you make that selection. So, for instance, chassis type, I could say, well, these are my fan resources, and my requirements are based on the chassis being a rack mount, and that allows you to again do these use cases. And try to make it easy to both explain and then easy to use. So, so those use case types allow for selections of chassis type. These are basically all of the type properties, but they're not necessarily called type in all cases. So you'll see chassis type, memory type, and processor type, and then that same kind of information, is available in the port protocol or drive protocol. So if that's an NVMe drive or a SCSI drive or SATA drive, whatever port, it would be something like, is this an Ethernet or a fiber channel port, et cetera, et cetera. So makes it again easy to do those kind of things. Oh, and I have examples there at the bottom, which I should have looked at as I was reading here. So you can see there's a chassis type of rack mount, memory type, not equal to DRAM. Well, that covers all of the NVDIMM types, and there are multiple types of NVDIMM. So using a memory type not equal to DRAM would be the way to cover all those things. And then obviously, as I just gave that same example, there's the drive protocol for like an NVMe drive. All right, and with that, I'm going to turn it over to Mike to talk about the 2024.2 release.
All right, thanks, Jeff. So 2024.2, if we go to the details, it's a pretty light release. This was mainly added to support additional changes that we made within 2024.1. So it was very much a quick turnaround at the request of another organization to flesh out a new set of features. So we only released the schema bundle. There were some other changes, not captured on this page, but largely it was to enhance some of the new locking configurations in the drive and storage resources. So that's really the highlight to show here, is that within 2024.1, we added a general locking capability for drives and storage subsystems, and this enhances it to give a bit more granularity as far as what type of information is surfaced and other types of knobs you may have over the lockdown capabilities. So if we go to the next slide, I'll go into those details. So there's 2 properties that go in tandem within both drive and storage. You could have this, you could lock down an entire storage subsystem with these properties or individual drives. It depends on your use case. But there's 2 properties, your configuration lock and your target configuration lock level. And so the semantics with these properties is that the 2 of them will restrict how in-band configurations of the drive or storage subsystem are allowed. So some folks may want to prevent any type of TCG functions from being configured in-band, and they want out-of-band users, administrators, to be the ones who own that responsibility. Or they may restrict being able to modify hardware settings on the drive. Maybe there's some hardware threshold that needs to be tweaked, that they want to manage only out-of-band for Redfish, but in-band users will have no access to that. And so the configuration lock property shows the overall status of the lockdown capability, and there's 3 values to this. There's enabled. It shows that in-band configurations are locked out. So if you want to do any type of configuration of the drive or storage subsystem, you need to come through an out-of-band interface. Disabled means that no locking is applied to the drive or storage subsystem. And then partial is an odd value here, but given some of the complexities of how drives and storage subsystems can be locked, maybe only some of the locking was successfully applied and some was not. And so that's where that partial state comes in, is that when a manager receives a locking request to apply lock settings to a drive, maybe only half the settings were applied. And so this is an indicator to the user that not everything was locked to your per your specification. You can't tell the manager to do a partial lock. This is just for reporting purposes only. Now, if we go to the next slide. So target configuration lock level specifies what types of locking do you want to apply to the drive or the storage subsystem. Right now, there's only one value defined. We call it baseline, and this will prevent an in-band user from being able to apply new firmware to manage security parameters such as any encryption keys with the drive or other types of hardware configurations. And so when this baseline lock level is applied, in order to do things like firmware update, you have to do that through an out-of-band interface. As I said, this is the only value we have right now for our configuration. We expect that other values will be added over time based on use cases for different environments. So this was very much envisioned, this baseline configuration was envisioned for the very simplistic, I do everything through Redfish. I do not want anyone on the host system to do any configurations in band. So that was our starting point. The exact definition for how these map to NVMe is all defined in SNIA's Swordfish NVMe model overview and mapping guide. So that mapping specification contains the details for saying when the baseline target lock level is used, these are the 5 NVMe commands that need to be locked out. So for NVMe devices, there's an additional set of properties within drive and storage. There's the configuration lock state property, and this is to surface NVMe specific information about the lock state. And so it shows each of the NVMe commands that are part of the lockdown capability, and it shows the status for whether or not the command was locked down successfully, whether it's supported for locking, or if the command's even supported at all. And so this is useful for when you find a system in the partial state. If you know you have an NVMe drive and you see partial, you can get further details from this property to see what about the drive was not locked down successfully. So we have some examples on the next few slides. So in this first example, this is a sample response from a service that shows an unlocked NVMe subsystem. So a user did a get on a storage resource. Configuration lock is set to disabled. The target configuration lock level set to baseline just as a default configuration, perhaps. And we see from the NVMe subsystem properties, there are 5 commands shown here as part of the lockdown capabilities. We see that firmware commit is unlocked. We see that the lockdown command itself is unlocked. Security send is unlocked. Firmware image download is unlocked. VPD write is just simply unsupported. So it's not even capable of being locked down. It's just not even implemented on that storage subsystem. Now, in the next example, this shows you a user trying to configure the lockdown capability. This says, so a user is doing a patch request on our storage subsystem. It says, I want to enable my configuration lock, and I want to set it to the baseline configuration. So this is expected to lock down the drive. It prohibits in-band configuration requests to the NVMe storage subsystem. And so at that point, only out-of-band management operations will be able to reconfigure the drive. So if we go to the next slide, this is effectively a good response back. So if you do a subsequent get and the drive was the storage subsystem was successfully locked down, we see, yep, the configuration lock is set to enabled. We see that all the supported commands are now locked. The only thing to note here is that VPD write is still listed as command unsupported. That's not a problem. If the command's not supported, you don't have to lock it down. So you've locked down the configuration request per the end user's expectations. Now, let's say something happened and there was some sort of issue with trying to lock down security send. So if we get back to status, we see configuration lock is partial. So this means that the user has to take action or has to do further investigation to see what went wrong with my lockdown configuration. And we see here security send is still unlocked. It's given it's in the unlocked state, we know that the command is supported. So we expected it to be locked down based on that request. So that's where further action is needed. All right. Well, that wraps it up for the 2024.1 and .2 releases. We'll open the floor to folks who have questions. And you may need to use a reaction to request to unmute.
And just to remind folks, if you want to ask a question, you can just request to unmute. And if you would like to, once we finish up the Q&A here, we'll close and then go to an open roundtable afterwards. So you're free to ask questions there as well.
I'm not seeing anyone requesting to come off mute. So let's move on. So well, thank you everyone for joining. We have a few links up here to get involved if you'd like. DMTF site, so standard/redfish to get all the normal Redfish material. We have the developer portal at redfish.dmtf.org. We have a public facing forum at redfishforum.com. We have the DMTF feedback portal and a link to join the forum itself if you want to get involved with the standard standard/feedback and standard/SPMF. Well, thank you everyone. We'll end the session here and switch over to the roundtable.
All right. Thank you everyone for attending.